Good morning, everyone. Thank you for joining and tuning into our channel. We are back with another session for this weekend. Again, this weekend we won't have any Amazonian speaker, but we have something great than that. We'll have one of the community hero sharing a stage with us and talking about her experiences about data. She's a veteran in data, have spent a lot of years, all of them, what we are on the recording. She has spent a lot of years about data engineering and been talking about data in different conferences. So most of the folks you would already be knowing her, but if not, no worries. Hold your breath. We'll get her soon on the stage. Just a housekeeping stuff. If you are been looking into our streams, we have done a multiple sessions. All of the sessions are in the same channel. If you have not subscribed it, I will share the link within the comment section so you can subscribe it today. We have our WhatsApp group, YouTube channels, or meetup page. Do subscribe either of them so you're up to date about the informations, different events what we have. We're going to have back-to-back sessions every alternate weekend, so please do join and learn from the best of it around the new technologies and how things have been shaping with data and Gen AI in space. So with that, let me introduce to our speaker. She was a community hero. She has been contributing a lot for Delhi NCR as a user group leader. She's been a veteran in data space, as well as she was one of the speaker for our data analytics day at Ahmedabad. She none other than Dipali Kulshrestha. Hey Dipali, good morning.
Hey Sanchit, good morning. Thank you for
Thank you.
this very welcoming introduction. So you
Absolutely.
really made me veteran in the data space, huh?
Yeah, absolutely. You are. I mean, I think at least better than me. I must say that. So
Yeah, I think
absolutely.
I need to accept that fact that yes, I am.
Yeah. See, I don't bluff it. I speak the truth. Yeah. Yeah. So first of all, thank you so much, Dipali. I know you've been running from conferences, from your offices. So really appreciate taking out time from your schedule for sharing your knowledge with the community. I know it's not that easy after going to multiple conferences back to back. So really appreciate that you took out time for our community to talk about the fundamentals of it. And I'm sure you're the best person to talk about that, given the things what you are doing in your professional journey, right? In different for so many years. So really appreciate that you took out time and help us to learn from it.
Sure, sure. Thanks, Sanchit. Thanks for inviting, first of all. And like these are the things which keeps us motivating, and like these are the opportunities where we can really structure our learning, whatever we have learned so far, and
Exactly.
like give others opportunity to leverage from our experience. So I'm happy to share my learning in this space.
Absolutely. No, I really
I
avail.
share my screen, Sanchit.
Yeah, sure. Just a second. So your screen is shared. I think currently we can stream. Yeah,
Are you able
awesome.
to see? Perfect.
Yeah, I can. So I'll take a back seat. I'll go to the back seat. The stage is yours. Let us know
Sure.
if you need anything. Okay.
Sure. Thank you,
Thank you.
Sanchit. Hello, everyone. Okay, let me go full screen as well. So, as Sanchit mentioned, my name is Dipali Kulshrestha, and I am an AWS hero and working into this data space, wearing multiple hats at different times. But yes, always been into this data space from last 2 decades. And today, I'm really excited to take you through this world of modern lakehouse architectures. But before we dive into that, let's look at that how we really got there. So traditionally, it all began with the data warehouses era, a time when data was mostly structured, sourced from transactional systems, and stored in rigid schema first platforms. And these systems were optimized for reporting, NBI, and these systems lacked flexibility. Those who if you have used like data warehouses, you must agree with that these were really less flexible, and when we try to scale or like do some performance tuning, it came with a high cost, and it obviously didn't play very well with the unstructured data, because gradually we got into the era where we like dealing with a lot of unstructured data, videos, clips, and all. So yes, data warehouse was not the right place to store all that. So as organizations do, their data started getting siloed, and each team had their own data sources which stored across different tools and formats to serve some specific business needs. So for example, if we talk about medical industry, so in medical ecosystem, different departments are maintaining data in different systems. Let's say patient data is saved in a relational database. Lab reports are maintained as PDF in some document management system, and radiology data is saved as images or maybe clips, and it is stored in some different system. And there is a separate data warehouse for billing and insurance information. So typically this is how data is scattered in within our like industry in different departments, and none of these systems talk to each other, and that's where data silos gets created. And now, since data is growing exponentially, managing this complexity is becoming increasingly difficult, and scaling each of these different systems is a really a costly affair. And that's where data lakes got evolved. So, data lakes offered the central storage for all our structured and unstructured data. Means now we can keep our relational data, images, documents, video clips all at one place. And cloud data lake like S3 based data lakes, they helped in getting scalable storage and offered low cost place to store all the data. But over time, these lakes turned into the data swamps. So without proper metadata governance or like quality controls, it became hard to know that what data is existed here, whether it could be trusted, who owns that data. So all these things become very tricky, and these data lakes become kind of useless. So they turned into the data swamps. And performance was also an issue here, especially for interactive workloads. So now to address this issue, Lakehouse architecture got emerged, which is a hybrid approach that brings together the low cost, scalable storage of data lakes and transactional integrity, schema enforcement, and performance of data warehouses. So, like it like tried to bring in best of both the worlds. So it supports asset transactions, open table formats like Iceberg or Delta. It also supports like time travel, versioning, real time data, and while you can do both like BI and ML workloads on the same source of truth. As you see here on the screen, like here we can deal with the batch data as well as like streaming data. You can perform ETL, you have a metadata layer on top of it, and then you are enabling as a consumption layer, you are enabling like BI reports as well as your data science and ML applications workloads. So this is a like quick comparison between all the three concepts. Data warehouses, it worked on structured data, while data lake, it catered semi-structured and unstructured data as well, and hence supported AI/ML use cases, while lake houses also introduced a metadata and governance layer. So like we can efficiently manage this access to this data. Now, when we move forward, so AWS has now strong native capabilities to support this lakehouse model. And what are the various services are participating in building a lakehouse? So it is typically S3, which is your underlying storage. And then you have your metadata and catalog created in Glue. You are accessing this data using Athena. And then for data warehouse, you are using Redshift. EMR you are using to create data pipelines, and lake formation you are using to like implement governance and define. So you can like define the fine-grained access controls. And typically you are using Iceberg data format, so it is in a unified format and can be accessible through different tools. And a lot of pattern got emerged out of this ecosystem using these services to support like batch data. So this is a typical pattern, like how we can use with these various services, and we can like deal with the typical flow of data. And so like we are sourcing data from here, and we are like visualizing it ultimately via like a quick site or like any reporting tool. And then this is a example of your batch data pattern, that you are ingesting data into S3 and then cataloging it into the glue. And then after, so here you are dealing with the raw data, and after cataloging you are processing, and so you are saving this process data back to the S3. It can be the same S3 or can be the different bucket, and then you are like querying it with Athena and then ultimately visualizing it via QuickSight. And this is the same batch data pattern, but with fine grained access control, where you introduce the lake formation as well. So, how it is working, that when user is actually querying the data from, and it is user is trying to query data from your S3 bucket. So, it is getting the like metadata information from via like lake formation. But in order to get actual access onto your S3, it is lake formation is wanting the temporary credentials to the user. So this user does not have direct access onto the S3, it is accessing via lake formation. So lake formation is wanting temporary credentials here. And so in that session, this user can actually get access to the data from here and metadata from the glue catalog. So this is how like lake formation like manage this permissioning into two different layers. And then this is the typical streaming data pattern, where you are getting the like streaming data, collecting it via Kinesis, and then introducing a lambda. So yes, you can send it to the like desired target. Here we are using like SageMaker, and then we are like creating some features out of it, and then ultimately visualizing this data. So these are the typical patterns which got emerged out of this like Lakehouse pattern. And nowadays, like since we are like creating a lot of GenAI applications, so this is how GenAI pattern is typically built. That when you are getting any data, you are like typically storing it in S3, and then you are like creating your pipeline into the EMR or EMR serverless, and then persisting that data into your data lake, then creating metadata on top of it, and then using Bedrock onto this data and catalog. And so like your users are able to query this data, and they are able to like if you are creating any chatbot application, so this through Bedrock, so it is reading from this bucket and you are able to get all the answers there. So this is the typical pattern. This is not the only pattern, but yes, these were the different pattern into this world of like data lakehouse. So now let's try to understand that, are is it going good, or like still we are facing some challenges. So if we talk about in large enterprises, so central data teams become really overwhelmed with ownership of everything. Because if you imagine a like huge data platform team, so it was really difficult for that team to manage everything. Because like they need to deal with the like infrastructure, they need to deal with the data, they need to deal with the access. So that's where a concept of data mesh came in, which really tried to federate the data so means it came with a concept that okay, lake in a box, rather than maintaining a huge lake at one place and then leading into the complexities and leading into the limits breaches, because every service has its own limits. So, sorry. So there is a concept came in that okay, why don't we federate this lake concept into different accounts. So it came with this data mesh concept. So data mesh is actually not a technology, so it's an operating model. And it says let's domain own their data. All right, so data mesh suggests that let's treat data as a product. Data is not a data, it is not just a raw data anymore. Let's treat it as a product, and which has like clear ownership defined on it, which has clear discoverability. And so for example, if you're trying to use payment data, as we were seeing in the last slide, so here like different users are dealing with different problems. So this user is saying that I'm not sure if patient data is available into this production environment. Another user is struggling that I don't know whether the table name for various data sets needed. I don't know the table names for various data sets needed for my analysis. So let's say you need to work on the patient data. You don't know what is the name of the underlying table, because as a user, you have just got access onto the Athena. You don't have access onto the underlying data lake, so you can see that exactly what all different databases and table names are there. So if you don't know the exact table name, it becomes difficult for you to really analyze or discover any data. So that is the key challenge here. And you don't know whatever data is existed into the data lake, you don't know how up to date is that. Because if you are working on some innovative application, you obviously want to perform your analysis on some latest data. You don't want to perform analysis onto like some historic or stale data. So you were not confident that exactly how up to date is that data, because you are just seeing the data. You don't have any like metadata information attached with that, that when it got refreshed, who is owning that, whether it is coming from a legitimate source or not. So you don't have all those details. And like if there are multiple tables with the similar name, so you are confused that you're not sure that which table data you should be using. So, to address all these problems, this data mesh concept came in, which proposed that okay, let's use this data as a product where apart from this like physical data, it will be having all this. It will be wrapped with the business metadata around that. Okay, from where it is coming, what all different attribute it is holding, what that different attribute mean. Let's say if I'm saying patient ID or patient number, what is the difference between these two? So what is the different business meaning out of it? So exactly, it provided a lot of business information along with your actual data. So this was the concept of data mesh. So if we talk about in AWS world, so Amazon Data Zone is a actually service which really helped us to operationalize this data mesh and simplify data access across various domains. So Data Zone is really played a game changing role here. So it provides a centralized portal where it like brought together the data producers and data consumers, and you have just a central portal where everyone can come in and can see that what data is available. So let's say in the medical example which we took, so the different departments, they are acting as data producers. And let's say if any patient is coming at the emergency, and doctor want to see the patient history, or doctor want to see the latest lab reports for this patient. So typically in the historic world it was not feasible, because there was not a central system. These systems were not talking to each other. So in order to see the lab reports, means doctor need to reach out to different departments to get the records of that patient. But here with this data mesh concept, with this data marketplace concept which Amazon Data Zone helped us to build, so when you are getting a central portal here, so that emergency doctor is simply going onto a portal and just checking the patient information there. So where each of these department has advertised the patient data, and as a consumer, anyone can see that. So you can imagine it like just Amazon.com. So where like different sellers advertised their inventory, that what different product they have, and we as a consumer can simply go onto the portal Amazon.com and can simply check the data. So based on the business metadata available there, because let's say if I want to buy shoes, so I'm not seeing actual shoes there. I'm just checking the metadata with respect to that shoes. That okay. So when I'm checking on the portal, I'm able to see that what is the brand, who is the manufacturer of this, and what is the color, size, style, and different bits. And accordingly, I'm like deciding whether I should be buying it or not. So it is the same concept. So it really helped us to democratize this data with a central marketplace. All right. So Sanchit, by the way, I'm just talking. Are there any questions in between?
No, Dipali, I think so far not. I think the audience are ramping up, so I think we are focused
Okay,
on your content. I don't see any question as of now.
sure, sure.
Yeah.
All right. So on this central portal, data consumers can search, they can preview, they can request access data. So let's say here I'm looking for some book data. So I will be able to check that exactly from like who has published this book data, when it got last refreshed. But so I will be able to assess whether it is the latest data or not. And then what all different attributes this data is having. So if I'm finding that useful, then I will simply request access, and then this access request will go to the producer of this data, and then producer will review the request and they can approve or reject the request. So if my access request is approved, then I will be able to query this book data into my account. So typically this is how this concept works. So organizations can really like apply metadata driven governance, and they can also track the lineage and enforce classification. So a lot of things can do on if data is available in this democratized way. Now, so we solve the storage issues when we like bring in the concept of data lake, and then we kind of with the like lake house, there was like problem with the like discoverability and like performance and all, and then we try to simplify that using the like data mesh up to an extent. But now even when we had all these things in place, but still like discoverability, so like the key challenges recently we faced were like with respect to discoverability and access issues. But now we hit another wall. So data scientists and data analysts, they needed agility, because let's say if you are working on some innovative use case that works on real time data or near real time data, for example fraud prevention. So if you are working on some fraud prevention use case, you want to see the near real time data. So if any transaction is happening, you want to act at that time. You don't want to work in a batch mode that okay, transaction happened today, and you will be processing this data and identifying or like flag it if there are if you think that this is not a legitimate transaction, so you will flag it in your like during your batch processing overnight, and then so by that time like fraud has already happened. So like use cases like fraud prevention and all, you really need to deal with the real time data or near real time data access. But when we have data available in data zone, so my bad, so data is available in S3 only. Okay, so data is there into your data lake only, while you are accessing it via data zone. So we are not making copies of data. But with data zone, I can simply access this data using Athena. But now, if I need to work on a real time use case, I want to really access this data using my EMR or SageMaker, or if I'm working on Gen AI application, then I need to directly access this data in my Bedrock. So if I want to integrate these various services and tools, so these are the like tool services I mentioned, these are like AWS native services. But what if my data is available at on-premise Oracle database? What if my data is available in Snowflake warehouse? And what if some of my data is available in Google BigQuery? So I need to integrate these various tools and services. And this integration takes at least like days or weeks. So if we are like spending that much time in integrating these services, these required tools, then we cannot deal with the like we cannot deal with real time data. So we cannot work on these innovative use cases like fraud detection. So Amazon like heard these problems, they took this as a feedback, and then they came up with like more innovative service which is named as like Amazon SageMaker Unified Studio. So this Unified Studio provided the big breakthrough we needed. it actually combined the capabilities of data zone with real-time analytics and machine learning tools under the single pane. So now analysts and scientists could spin up notebooks, they could run SQL queries, they could analyze data, train models, and even build Gen AI applications all at one place without raising different requests. So if you just got access onto your unified studio, onto your project, then yes, all these tools are natively available for you. You really need not to wait to get access or provision these different tools. Okay, so this unified studio, it like provided the various capabilities. For example, so you can discover this data from your data lakes, data warehouses, federated catalogs. So here we are not just talking about the lakes and warehouses which are available in AWS, but it can be your third party or on-premise data lakes as well. And then you can gain insights by querying so Redshift or Athena, so you can like perform some analytics onto this data. And then it is also integrated with Athena EMR and Glue, which gives you the compute. And then you can build, train, and deploy your like models. And so like it is fully integrated with the SageMaker. And then if we go one step further, it is also integrated with Bedrock, so you can seamlessly build your Gen AI applications. So this is the typical architecture that how SageMaker Unified Studio is typically so how it like typically brings everything together. So I'm not sure, it is not clearly visible. So this central box, if you focus on, so this is your central SageMaker account where you actually create the domain. So this is your governing account, while at left side you are seeing the various producers who are actually data owners, and then on the right hand side you are seeing the various consumers. So you are doing all the admin activities onto this central account where you are creating the domain. You are like creating the different projects for your different producers and consumers, and then you are associating your producers. So this is where the association is done. So you are associating your domain with your producer and consumer. So let's say you are owning a data lake account, so you will be advertising all your like data lake catalog onto this central catalogs. So here you are simply advertising it. Your data is still here only into this S3. So you are simply advertising your catalog that okay, this is the different data sets I have, and these are the like metadata, business metadata associated with that. So any user who want to use any data here, so this user will come onto this central portal, and this user will check in like plain English keywords. Do we have some data, let's say, with respect to transactions, with respect to credit cards? So the user will simply like try to see in the plain English keywords. And if there is some related data, you will see all the tables underneath that, okay, with sales data, with transactions data, these are the different tables. So you can simply go to each table and then can see the metadata associated with that. So if you think that yes, this data is useful, so this user will request access onto this catalog. This access request will go to the producer. So this is the like producer project. So this is data lake is the producer here. So this request will go to the data lake producer project. Here, the admin of this project will review the request and they can approve or reject. If this request is approved, then this user can actually access this data into his or her own account using the choice of services, whatever. So I may want to use it using like notebooks, I may want to use it into the EMR, or maybe I'm working on some CI/CD pipeline, so I just want to use it via Git. So these are the various tools and integrations available. So typically, conceptually, this is how it works. But now let's see it in action, that how it actually works. So here is a like demo.
Here I have created this domain AWS events where I have
So Sanchit, can you please confirm if you were able to hear the audio?
Yeah, Deepali, I can hear your audio.
No, audio into this demo video.
enabled all the
Yeah, can you just
blueprints
play?
and few bedrock models.
Okay.
If I go to this portal,
So I'm not speaking. Let this video play then.
here
Sure.
I have created this domain AWS events where I have enabled all the blueprints and few bedrock models. If I go to this portal here, I can see this screen where I can see the various projects available. So here I have created two projects. Let me go into this data AI project. So here, this is your landing page where you can see its integration. So it is integrated with Bedrock, and by default, you get integration with Git, and we have also got integration with Notebook, etc. So if you go to data section here, this is where you see all the available catalogs. So this is the Lakehouse catalog available here. Redshift catalog is also available. Similarly, S3 catalog is also available. So these are the unified catalog available here. And in Lakehouse catalog, you see the data which is managed in Glue catalog. And here, so this AWS catalog data, so this is managed in Glue catalog, while this is specific data. So this is the federated catalog, because primarily this data was managed in Redshift and then it is published to Glue. So this is how you can see the federated data as well. And if you need to bring in any other data into this unified catalog, so basically for external connections, you can actually create a connection here and you can bring in data from various other sources, including Snowflake, Oracle, BigQuery. So you can bring in this data from third-party sources, and this is again known as the federated catalog then. All of these data sets, so this is the database and these are the tables inside this database. So each of these table you can either query with Athena, Redshift, or EMR using Jupyter Notebook. So for example, let's try to query this table using Athena. So you are able to query this table using Athena. Similarly, now let's say if I want to query this federated data using my EMR job. So how I can launch EMR? So in the build section, you get all the various tools which are needed for your developers, data engineers, data scientists. So in build section, you get this Jupyter Lab. So here I have this Jupyter Lab available. So here you can simply write your commands. And as you see here, I have written some PySpark script. I have created a session, and then I have created a data frame here, and I'm able to query this data. So this is how you can access this data using variety of tools. Now, apart from these things, you can also create visual ETL workflows here. So here I have created one visual ETL pipeline. So let's have a look onto that. So here in this pipeline, I'm joining these two tables or two data assets, then performing some aggregation, and finally saving them onto this table, which is named as customer behavior by state, and it is part of the sales marketing database. So let's go to data and have a look on this one. So this is the table which has been created by my visual ETL job. We can again query this table using any choice of tools. So let's say this time I'm querying it via Redshift. So you are able to query this data seamlessly. Now, let's say I have created these data sets and I want to publish these data sets as data asset or like as data asset or maybe I have created some models which I want to publish them so anyone else can use them. So here, if you see the asset section, so you can see the inventory where what different assets you are dealing with. In the published section, you can see the list of assets which it means this project as data producer has published to the unified catalog. So these published data assets can be accessed by other consumers. So this specific producer has published few data sets with respect to sales, products, etc., etc. So now let's go to another project. So here I'm into this marketing project. Now, as marketing project, if I check the assets here, so it has not published any data asset, but yes, I want to create, let's say, some data product where I need to access the sales data. So I came here onto this central unified catalog and just went into the discovery section that is there any data set available with respect to sales? So I just tried to query here. Sorry. So it gave me like there are two different data assets which are available for sales. So let's check that exactly what data it holds. So here you can check the metadata of this data, that exactly from where it is coming, who is the owner of it, and then what all different attributes are available into this table or data assets. You can also check the lineage information, that exactly from where it has originated, what all transformations it has gone through. So you can see the beautiful graphical representation of it. So this is how you can also see the data lineage of this specific project. And if you think that, yes, this is a relevant data set for me, then you can simply go and request the subscription onto this request. Okay. So you can simply request the subscription, stating the reason that why you need this request. Currently, I'm canceling this. And this request will go to your publisher project because they have published this data. So this request will come here into the publisher project subscription request section. Here you can view the request and that who has requested it, for what purpose. You have control that you want to give them full access or fine grained access. You can review and you can simply approve or reject this request. If you approve this request, only then your consumer project can see this data into their unified catalog. Means here. So only then this data set will be visible into their unified catalog. So they can simply start using it by querying Athena, Redshift, or a notebook. Now let's say that, okay, yes, I can access this data. Now here, this is generally what data scientists do. Now, let's say if you want to create some Gen AI application. So here, I can also build my Gen AI application. So let me go to my producer project because that is where I have built my application. And go to this chat agent. So under my app section, I can see the applications which I have created. So this is the application I have created. And you can simply start using this application as any other Gen AI application. You can start playing with it. So this is how it offers very cool features. It integrates everything together with respect to data and AI. So it gives us really true unified experience and it expedites our data cycle.
All right. So this is the demo on like key features which Unified Studio offers. Uh, so like to me, how I take it, Unified Studio or Lakehouse, you don't think it as a storage or like architecture. It's not just a storage or any architecture pattern. So it's actually an experience. So this is where your governance, collaboration, agility, innovation, everything is meeting at one place. And AWS provides every building block. Your like goal is to tailor it to your business needs. And with the studio, especially with like SageMaker Studio, and it is also known as like SageMaker, like a next gen application, next gen SageMaker. So with this, you are not really just unlocking your data. So you are unlocking the possibilities here, because this is giving you the edge that you can work on various innovative applications. And we would like to see that what innovative applications you'll be working on this one, how you will be using this specific service here. So if you build on any innovative applications, please do let us know, and we would love to host you in these forums. And so, just a quick recap that what all things we have covered, and what all problems you are facing, and how different services really helped us solving those issues. So initially we started with the like data warehouse, and sorry, I don't have any like recap slide here possibly. Yeah. So we started with data warehouse. So in data warehouse, the key challenge was that we were able to deal with the structured data, but it was not working very well with the unstructured data. And it was costly affair when we were like dealing with performance, etc., or like interactive queries. So that's where we created data lakes. So data lakes were behaving well because it gave us like centralized storage for structured, unstructured, and semi-structured data. We were able to dump all the data at one place, so scaling was easy, it was cost effective. But still, it gave us performance issues. It was not very well discoverable, because data scientists and data analysts, they were lost at exactly where to see the specific data, because when you have a lot of things available just at a single place in a single bag, everything is there. So obviously it becomes tricky and difficult to find the specific things you are looking for. And that's where this concept of data lakehouse came in, so which like tried to give us the storage and access performance efficiency with that. But it also didn't solve the like this discoverability problem very well. And that's where this concept of data mesh came in. So it was just the concept, underlying technology, underlying storage remains the same. So it was a concept that, okay, now let's advertise this data as a data product. And where Data Zone helped us to really create one central portal, and where we could advertise this data and we could search that data. Then it was not giving us the enough agility, because yes, nowadays everyone wants to deal with the innovative real-time use cases. So SageMaker Unified Studio gave us this opportunity, that it came up with everything like integrated at one single space. So you don't really need to wait to get access to your data or different tools. You can do anything like at any time. So this is how these different services have evolved so far, and obviously it is not the end. We are yet to see what next is coming our way. So we will like see that how we are leveraging these different services. And here you can connect with me on LinkedIn, or you can like I have also created like some courses on data engineering, DevOps, Gen AI, and latest one was on this like creating the secure data lakes in AWS. So you can scan this QR, have a look on these courses. It might help you in your learning journey. Before we wrap up, Sanchit, are there any questions?
Thanks, Dipali. Yeah, we do have two questions. First is uh, the same way, I think, correlate what you just mentioned few slides back. Hey, I'm
Mhm.
learning advanced SQL and I'm aware about of S3 buckets and EC2, but I don't know the roadmap. Could you please simplify or give me an example for a beginner or entry level data analyst to do some interesting job on AWS?
Okay. So I would recommend just pick one simple use case and the journey which we just talked about, that is starting from data warehouses to data lakes to data lake houses, and introducing this data mesh concept, and then came up with SageMaker Unified Studio. So I would say don't just straight away go onto the SageMaker Unified Studio. You just build from scratch and understand that exactly what all different things you need for your application, because everything comes with a cost. So start small. So start from the scratch and understand that exactly what are the problems there, and why you need to create it as a lake house, or maybe why you need to create it as a unified studio. So that will give you the enough confidence and enough understanding, that because every service has its own purpose. So you need to understand your business need and choose the service accordingly. And if you are struggling, I think this here data engineering with AWS is the course where you will get to see the structured learning, that okay, how we are like joining these building blocks. So maybe you can opt this if you are a really beginner. I hope that helps.
Yep, absolutely. And again, if you have follow-up question, please post it in the chat, right? The second interesting question is, should we build data platform with AWS native services or SaaS tool like Databricks and Snowflake? How to decide? This has become very important for a lot of customers. Please advise.
Rightly said. Very nice question, and very valid question in today's world, because like we have these different services which more or less offering the similar capabilities. So I would say all these are the competitors, or everyone has its like own unique niche. If I talk about Snowflake, so Snowflake is a very good offering when we need to build our warehouses. If I talk about Databricks, so Databricks is helping us to create the lake houses. It is helping us to create these data lakes. But so you need to understand that exactly what is the tool stack you already have in your organization. So because you need to build further on to that, because we always prefer to use the native tools. So if you are working on AWS, you will look for the native services so you can integrate easily. Seamless integration is there, and also you are like keeping it low maintenance. Because if you are trying to use different tools and different services from different vendors, then integration will be time taking, and maintenance, ongoing maintenance will always be there, and you will need to have like different capabilities within your organization. So you need to assess that exactly what is your, so it's like any other competitor when we go to market. So like we assess any product with on different parameters in terms of cost, in terms of the support available, in terms of the in-house capabilities available, or what do you already have. So if you are working on, let's say, like Databricks ecosystem, then might be Databricks. If you are like creating your data lakes or lakehouse onto the Databricks, that will work well, possibly for your needs. And if there are any specific things, because the latest thing which AWS introduces with this SageMaker Unified Studio, that the tooling integration. So I'm not sure if Databricks offers that. So currently, I guess no. So if you are looking for that kind of integration, then now AWS and Databricks have also collaborated. So you can like join your Databricks lake with this unified studio, and can get this tools integration, and can get going with your like real time use cases as well. So I think answer is not straightforward or easy, but yes, different parameters you need to consider, that what all different technologies you are already using, what capability you have in house, and you need to assess the costing and the support provided with these different vendors.
Yeah. And just to add what Dipali mentioned, because I've got into this scenario in the past multiple times. See, end of the day, if you talk about Snowflake or Databricks, both you can run on AWS as an infrastructure. And now you can also integrate with SageMaker Unified Studio, as Dipali just mentioned, right? Uh,
Yeah,
it
yeah.
is, in a very layman language, I would say it's different flavors of ice creams. Some are sugar free, some are full of sugar, chocolates. So it's on you individually, on your business problem statement, the maturity of your team, the kind of use cases, as Dipali mentioned, the sequels and kinds of stuff. What is the appetite of your organization in terms of how they want to do it? Now, for example, there are certain organizations who wants to actually build their own custom IPs, proprietary IP sort of a stuff, right? Of the data products kind of a platform. Now, in those scenarios, you have to always see AWS infrastructures go for open sources kind of services like Spark and all, not natively managed services. So that's one of the use case around it. Some of them are more like I would say DNB kind of customers want to run faster with large data processing kind of a thing, right? In that scenario, you have to see it as different thing. Some of them are fintech customers who are very much compliant oriented, want to make sure the security of their data of their end customer and all. So there are, as Dipali mentioned, there are different permutation kind of use cases. What the simple approach which I always do,
Sorry,
based
Sanchit, your voice gone. Yeah.
yeah, sorry, what the simple approach which I always do, and I think that can also help in your scenario, is a grid based approach. On one column you just write down what are the different parameters given the industry and given the segment of the users, and on the other side you just write down what is like the others offering you're comparing, and just create a simple grid of it. You can easily decide based on a given customer or metrics how exactly or what tool will work best. Like as couple of parameters Dipali Ansho mentioned, right? Performance, cost, compliance, technology, programming language, what they want to do, data scale, processing, XYZ, right? That's how you can create a kind of a tabular matrix, and you can fill out that matrix, and that will help you to decide what exactly. But again, this is not like that. As always, Swami do mention in his keynote, right? There is no one single strategy that can address all of your customer. This is that scenario where you cannot say that X is going to work for Y. Even for I have seen in my tenure that for same fintech customer, one department may go for Databricks, another may go for AWS native. So it is their particular use cases, the kind of audience and kind of team what we are addressing based on their requirement. You have to decide that.
Yeah, and it's like depends on your organizational strategy as well, because at times organization prefer to go multi-cloud so that they don't have dependency on one single vendor, and at times they want to just go ahead with just one single vendor. So yes, they can simply depend on them, and they can get the guidance and they can get the best out of that vendor, and they can get the good discounts as well in those terms, because then you have a clear long term vision in there. So it depends on various factors actually. And yes, then obviously you need to do some POCs as well, because if I recall my experience with Snowflake, because if you have, let's say, data lake created in AWS, and if it is not in your, let's say, unified format, which is like Iceberg, etc., uh, and then you are trying to use that catalog into Snowflake, then Snowflake does not really allow to directly access it from your Glue catalog. So you need to make a copy of data into a Snowflake. So you need to maintain a local catalog there, and then you can further use it. So you need to do a POC to understand if there are any such restrictions there. So various factors, that exactly where is like data is stored and how it can be accessed via different services, because obviously you just want to keep one single copy of your data, you don't want to maintain multiple copies there.
One more
All
follow up
right.
question.
Mhm.
Sorry, Deepali, I think one more follow-up question. Could you please provide some open source projects? I think this is from the same light. They want to improve their journey on data engineering. So, is there some sample projects what you can provide open source?
Honestly, we need to Google for it. So there are a lot of like AWS repositories are there where they have a pool of open source projects. I'll try to find one and share the link into this
Yeah.
stream.
Or what you can also do is you can Google AWS workshops. So AWS do have something called as immersion days. This immersion days is like a immersion days are meant for their different customers and partners, but the outcome is a very exhaustive document and step-by guide what they publish, which are publicly available. So you can pick up some of those immersion days guide, which has screenshots and sample data, code, and everything, which I think will be a good start also from an open source project perspective. And absolutely, I think I'll work with Dipali to post a couple of those references in the comments of this video, which you can get it from our channel.
Yeah.
So, Dipali, I think that's pretty much what I can see in our comment section. Uh,
Okay. Okay. So we are on time. But yes, if you have, when you will really start exploring these services and concept, and if you are stuck or if you need like some guidance there, feel free to reach out to us later on as well, and we'll be happy to guide you.
Absolutely. And again, for all the audience who are watching this video on demand mode, please don't hesitate. Put out your question in the comment section of the video. I'll work with our speaker to get all of them answered. So please don't hesitate that we were not able to participate for some XYZ reason. Still, you can go through our video and ask any questions you have.
Yeah.
Cool. I don't see any questions. I feel like our audience are good. Once again, Deepali, thank you so much for walking us through as well as giving us this demo about a unified studio. I am sure that is going to be really helpful for me and for our audiences. So thank you once again for spending time with us on the weekend. And I'm sure we'll bug you more. I'll reach out to you more for similar sessions in the near future.
Sure, sure, Sanjay. My pleasure. So nowadays it's like we are like exploring these various new services and concept, building some like dummy use cases maybe, and then like trying to share that knowledge so yes everyone else can leverage. And yes, as I like called out in the beginning as well, so if you are working on some innovative use cases, we are really keen to see that what innovations you are like building using these tools, and we would love to host you.
Absolutely. Thank
It's a
you,
mutual
Deepali.
learning platform. It's not like that yes we are teaching and you are learning, we want to learn from you as well.
Correct. I think it's for community by the community, right? So this is a larger forum. So please, I completely agree with Dipali. You can always reach out to us on our LinkedIn. Just DM us that we have this topic. This is what our schedule availability looks like. We'll always be happy to host in any of our user group forums. So please do reach out to us. We always want to love and see what exactly you guys are building, or maybe what scenarios or experiences and learning you have from different of the services, because it's an infinite learning. No one can here say that, okay, I know every services out there. I mean, for all of us also. So with that, thank you so much, Dipali, once again for spending time with us on from the weekend. We'll really look forward from other your conferences, and best of luck for more of them. And thank you so much, audience, for tuning in on Saturday to learn from us, specifically from Dipali, about her experiences and this new services. Stay tuned. We'll have one more session specifically on SageMaker Unified Studio, detailed out deep dive on July 12th. That will be done by one of our Amazon friends. So stay tuned. Do subscribe our either of the social media platforms so you're up to date about the timings and the links and other stuff. Till that time, I'll take a leave. Stay safe, stay secured. We'll see you in the next session. Thank you. Thanks, Ipali.
Thank you. Bye.